Okay, we're going to look at Chapter 3, the first section, where we're looking at quadratic functions. The objectives in this section are to recognize characteristics of parabolas, graph parabolas, determine a quadratic function's minimum or maximum value, and solve problems involving a quadratic function's minimum or maximum value. So when you have a quadratic function in the form f of x equals a times the square of x minus h plus k, with a not equal to 0, this is in standard form. The graph of f is a parabola whose vertex is the point hk. The parabola is symmetric with respect to the line x equal h, and if a is greater than 0, that is to say a is positive, the parabola opens upward. If a is less than 0, that is negative, the parabola opens downward. The graph f of x equals the square of x minus h plus k, a not equal to 0, we want to do the following steps. Determine whether the parabola opens upward or downward. Remember, if a is greater than 0, that is, if it's positive, it opens upward. If a is less than 0, the parabola opens downward. Determine the vertex, and remember the coordinates of the vertex are hk. Find any x-intercepts by solving f of x equals 0. Remember, f of x are your y values. So another way to think of this is y equals 0. The function's real zeros are the x-intercepts. So if you solve this equation and you get imaginary numbers, then the parabola doesn't have any x-intercepts. In order to have x-intercepts, the solutions to this equation have to be real numbers. Find the y-intercept by computing f of 0. Plot the intercepts, the vertex, and additional points as necessary. Connect these points with a smooth curve that is shaped like a bowl or an inverted bowl. So let's take a look at this for the parabola f of x equals 1 minus the square of x minus 3. So the first thing we need to do is to put this in standard form. Alright, so what we're going to do is put this in standard form, and we realize that the standard form, and technically it really is in standard form, but the standard form has the square of x minus 3 times negative 1 first. And notice that this 1 is positive. Since there's no sign in front of 1, that's actually a positive. So now that the 1 isn't in first position anymore, we have to actually put a positive or an addition sign in front of it. All right, now notice here, a is negative 1. So this actually could be thought of as having an unwritten 1 in front of it. So we could think of that as being a 1 there, even though typically that would never be written. And we see that our a is negative 1. So one of the important things to determine right off the bat, now notice that's negative, or less than 0, and that tells me right off the bat that my parabola opens downward. All right, I see, now remember the standard form of the parabola is a times the square of x minus h plus k. So the h is the number in the parenthesis that's being subtracted from x. So notice h is a positive 3. I'm subtracting a positive 3 from x. K is whatever is being added to this quantity that's being squared. And in this case, that's a 1. So K is 1, H is 3. So we have some real important information here about our graph. We know how it opens and we know its vertex. And I'm going to just do a rough sketch here. Alright, so notice the vertex, so this tells me that my vertex is 3, 1. The point whose x-coordinate is 3, whose y-coordinate is 1. So notice that what that is telling me is my vertex is here, and this parabola is going to open downward. So once you know how the parabola opens and you know the coordinates of the vertex, rough sketch the graph and think about where the vertex is and how the parabola opens. And when we do that, we see that there are x-intercepts. So I don't want to needlessly solve for x-intercepts if there aren't going to be any. I can tell that by plotting the vertex and looking at how the graph opens. Sometimes there are not x-intercepts, and I save myself some unnecessary work by determining that before I go to solve the equation. So 0 equals negative the square of x minus 3 plus 1. Alright, so I want to solve this by the square root property. So I'm going to add the square of x minus 3 to both sides. So on the right side, that gives me the square of x minus 3 when I add that to 0. And on the left, I just have a 1. So remember what the square root property says. The square root property says I can lose this exponent of 2 if what I'm squaring on the left is isolated. I can lose the exponent of 2 applied to what I'm squaring if I replace it with plus minus square root applied to whatever's on the right side of the equation. Oops. So let's find the y-intercepts. And that simply comes from replacing x with 0. So I want to calculate f of 0. So wherever I have an x, I put a 0 instead. So I get negative the square of 0 minus 3 plus 1. So negative the square of negative 3 plus 1. Negative 9 plus 1, which is negative 8. So the x-intercepts are 2, 0 and 4, 0. The y-intercept is the point 0, negative 8, because remember we let x equal to 0. when we went to find the y-intercepts, we let y equal to 0. And the axis of symmetry is always the vertical line whose equation is x equal to my h. So this is the vertical line, x equal to 3. Our h was 3. Okay. So we have enough to get a rough draft of this. Here's the axis of symmetry. X equal to 3. And we know that our -8 was our y-intercept. Okay, so that is a rough draft of our graph. I want to show you how to graph this in Mathematica, a program, very powerful program, available to you on the computers at MCTC. The first thing you do is you hit this Microsoft symbol, go to All Programs, and you'll see Wolfram Mathematica. Click on that, and then don't select the kernel, but select Wolfram Mathematica 10.1. And I'm not sure, this is my laptop from MCTC, and I'm not sure if 10.1 is the latest version. It's what's on my computer. Alright, and I actually can just put this in by using the plot function. Notice functions begin with a capital letter that are defined, functions that Mathematica has defined within it. And I can put the function in exactly the way it was given. So I put in the function 1 minus the square of x minus 3. And then I have to give a range on x. I'm just going to go from -10 to 10. If you're using a graphing calculator, that's like giving a window on the graph. This is the x window, so it gives the range of x's. A lot of times you don't have to give a range of y's, but if you do, that's called plot range. So notice the P has to be capitalized and the R, that's one word, plot range. And I use a dash and the shift of the period, and I tell it, and it'll turn into an arrow when I type my next entry. I want to take y from -10 to 10. Now this may or may not be a good range for my y, so when I look at the graph, I'll tell it that. I'm going to tell it to label my axes. And these words have to be spelled just like I'm spelling them. So I want to label it XY. And I'll put in a actual label of the plot. And I'm thinking that this is the way I put it in. If I see that it doesn't come out right, I can go in and change it. And what I'm going to do, because I want this to come out nicely, what I'm going to do is I'm going to put that in. I'm not going to use the caret button, but I clicked on palettes in the basic math assistant palette, and that gives me palettes very similar to those you use in my math lab, where I want that label to look good. And so we'll see if I put the information in correctly for the label. We'll see when it graphs. So I'm going to hold Shift and select Enter. And that is telling me that, and I'm sure this is where the problem is. I think I have to put this in quotes. So I'll select this bracket that's outside of my input. Oops. And you know, I may not need these at all, these braces that I put in. Oh, let's see, plot label. I'm going to just take this plot label out. I'm pretty sure I forgot how to put that in for now. Let's see. There shouldn't be any problem. Oh, I forgot to put the X. That's been the problem the whole time. I forgot to, when you give the range on X, you have to say that that is the range for X. And I totally forgot that. So maybe my plot label was not the problem. That was the problem. All right, let's see. Okay, maybe I don't need that. Okay, so there's our graph, and there are a variety of other things that you can do with it. I do want to mention that you don't have to put all these options in. The bare minimum for graphing this, and because it is a program, things have to be very specific. Here's the bare minimum for graphing, and that is to just give the name of the function. And notice when you give the function, you give the expression that equals the function. You don't put y equals in here or anything, just the right side of f of x equals 1 minus the square of x minus 3. And merely the values that you want x to range through. That's all you have to put in to use the plot function. And notice how different it looks when I don't give that range on the y. I don't give that plot range information. Look at how it came out. But that's the bare minimum to get the graph. But notice how I improved the graph quite a bit by giving it the range that I wanted y to be, and that's the portion of the graph that says plot range. All right, and I am going to tell it to make my graph thick. I just want it to be a little thicker than it is. All right, and there it is. And if I wanted to, I can put arrows on this. I'll use the graphics drawing tools. So that pops up as a palette. And let's see. I want those arrows to be blue. Okay. So I selected arrows, and I can improve my blue to kind of better match this. Okay, let me try that one more time. Anyway, I won't worry with those arrows right now. Um, but this is, if you want to use Mathematica, it's a great program. And there are, as you go further in the course, there are going to be some times that it's really great to have a graphing tool. So this is a graphing tool that's available to you at MCTC free of charge on the school computers. So some of the problems that you'll do in the future, not very many of them, actually you don't have to have a graphing utility, but it does provide you with a free, wonderful graphing utility. All right, and you can totally skip this portion of the video, but I do want to start kind of showing you how to use Mathematica. And it'll kind of be your option whether you use it or not. So here's an exact version of the graph. I could improve this a little bit and get a little closer by not going so high with my plot range. I probably only need to go to 2, and so then you kind of get a little bit better view by changing that. Because we know that the highest point on the graph is that vertex of 3, 1. So we don't really need to go way above way above 1 to get a good picture of the graph.